Hi, Algebra 2. Today we're going to be talking about expanding logs. So before we get that there, I want to remind you that these are the special logs that we've talked about before. Make sure that they're listed somewhere on your green sheet. When we get done with this video, you can go ahead and write them down, go back to review them. Okay, so we're going to talk about different properties of logs today. We're going to talk about a product property. We're going to be talking about a quotient property and the power property. But before we start doing that, let's talk about what happens with our product property when we have something, like an exponent rule. So let's kind of refer back to what would we do here if we were given these exponents and we were going to multiply them. Well, hopefully you would tell me because they're the same base, what can we do with their exponents? What would we do here? Well, we would add them, right? X to the 2 plus 3, and we'd get x to the 5th. Okay, so remember I told you that logs were kind of the inverse, is the inverse of an exponential. So these are exponentials and their exponents being added. So think about the property now. So we're going to like undo this. Remember, it's doing the opposite. So let's go look at the property of log here. So we're going to be expanding logs. So that means we're trying to get more than one log. So we're going to start off with something that's one log, and then we're going to expand it to 2 or more logs. So here's the key. You look to see how many, I don't want to use the word terms, but if you were to look at this as how many variables do you have here, or you can say numbers, well, you would tell me 2. So you're going to need 2 logs here to expand this. But if you had something like this, I'm just going to make up something. Because you have 3, you're going to have 3 logs in the end when you're expanding them. Okay, so that's like the first thing let's talk about. And then what are they doing? What kind of operation are we doing to these? Well, hopefully you would tell me that we're multiplying them. So remember when we're multiplying, what do we do to the exponents? Well, we added them together. So you're going to have to think if they're being multiplied, we're going to eventually look at them as we're adding, okay? So look at this first one. So here's just without any numbers, and we're just showing you the property here. It says log base A of u times v. So we're going to kind of split this out, and we're going to take care of this u first. So look what we do. We have log base A of u. And then we have this v. Well, remember, we're expanding it. So we want to give a log to the u, and we want to give a log to the v. So all we're going to do is we're going to take the same log that's written, and it's kind of like you're distributing. You're distributing that log to the u and to the v. So now we're going to write log A of v. So remember, multiplying goes with adding. So if you see multiplying here, you're really going to be adding the logs eventually. I know this is hard. This is like kind of weird, and it might take a little bit of time to kind of process this. But always think of when you're multiplying exponentials together, you're really adding the exponents. So same thing with logs. When we're multiplying logs together, when we're expanding them, we're really adding them. Okay, so let's just kind of expand this real quick. Let's just expand them to kind of get an idea of what's going on. Okay, so how many variables do we have? Well, we have 2 of them, right? So we're going to have to eventually have 2 logs. So I'm going to split this out, and I'm kind of going to go step by step. This is really saying m times n. So remember, think add. So we're going to give the log a to the m, and we're going to give the log a to the n. And because it's being multiplied, you need to think Well, I'm going to have to add these together. And then that's your answer of expanding. We're just expanding them out. That's it. All right, let's move on to number 2. Okay, so what do you think here? How many variables or letters do you have? Well, we're going to have 4, so we're going to need 4 logs. So remember, this is basically saying m times a times t times h. So we're going to give the log a m, log a, log a t, log a h. And then instead of being multiplied, we're going to add, like we would add the exponents together. So we're adding the logs together. Does that kind of make sense? All right, let's go to number 3. Okay, so remember, think 19 times x. So we have 2 logs here. So we're going to do log base 3 of 19. So that goes to 1 log, and then we need to do log base 3 of x. And because they're being multiplied, we add. And we're finished. Okay, you guys try number 4 on your own real quick. Okay, so we had 3 variables, so you need 3 logs. And you guys, what do you remember about this? What is this called? Well, I said it's called a common log, so what is that really representing? A 10 right there. So you definitely, well, you don't necessarily have to write the 10 if you don't want to. When we're evaluating them, you might want the 10 there, but you don't have to have them here. So this is fine. Or you could have written log base 10 of 2 plus log base 10 of x plus log base 10 of y. So this can be either or. Okay, so now let's go down and let's put this into practice. Okay, so now we're expanding this so that we can evaluate what the log base of 5 of 21 is. So notice it gives you 2 numbers. It gives you log base 5 of 3, and it also gives you a log base 5 of 2. And it's saying, hey, log base 5 of 7, sorry, not of 2, equals is approximately 1.209. And if you do this in your calculator, it gives you approximately that. And log base 5 of 3 is going to give you approximately 0.683. So let's see if we can rewrite log base 5 of 21 to be numbers of 3 and 7. So how can we maybe rewrite 21 with a 3 and a 7? Well, hopefully you would say, I can say, well, 21 is 7 times 3. Wouldn't you agree, everyone? So now guess what I have? I have multiplying, and I could expand this so that I can give 2 logs. I can give a log base 5 of 7, and I can do a log base 5 of 3, and then I'm going to add them together because this is a multiplication problem, so I'm going to add them. Now look what I can do. I already know, because it tells me in my problem, it's given that log base 5 of 7 is approximately 1.209. So I can just substitute that log base 5 of 7 for 1.209. And then I can do the same thing with log base 5 of 3. I know that is approximately 0.683, and I can add these two numbers. So add these two numbers together, 1.209 plus 0.683, and that's approximately 1.892. And then that's my answer. How do you guys feel about that one? Okay, let me just do another one real quick. Just kind of give you an example. What if it was something like this? Log base 5 of, let's say, 9. Well, how can I rewrite 9 so that it can either be log base 5 of 3 or log base 5 of 7 or both? Well, I could say that 9 is equal to 3 times 3, correct? So I could do log base 5 of 3 plus log base 5 of 3. And so then I go ahead and I replace this with 0.683 plus, well, this is the same thing, right? So 0.683. And let's see, let me get my calculator out because I just made this up. I don't have it right in front of me. See what it gives you. Okay, when I did it in my calculator, it gave me 1.366. So make sure, check my math, make sure that I'm correct, but I think that's what you get. Okay, so does that help just to do another one like this? Okay, so now we need to do the quotient property. Okay, so let's go back to what we know about exponents. So if we were given this same base, right? What do we do with the exponents? Well, hopefully you would tell me we subtract them. So we end up getting x squared. Well, that's the same thing going to happen when you have a division or a quotient. Remember, quotient just means the answer to a division problem. So if you're going to have a division problem, you're going to expand the logs so that you give log a to the u and to the v, but this time you're going to subtract them. So just think of like the division fraction bar as an equal as a subtraction, and it kind of helps you to remember that. Okay, so do you see how that works? Kind of the same way, but you've got to remember that division and subtraction go together. Okay, so let's expand this one. Okay, so how many logs should we have? Well, again, we have 2 logs because we have 2 variables. So I'm going to do log base A of m and log base A of n, but this time, instead of adding, I'm going to subtract them. Because if I add them, then it seems like it would be m times n, but this time they're being divided, so I have to subtract them. Okay. Pause if anybody has any questions and help each other. Okay, let's do some more and see if we can get the hang of this. Okay, so how many numbers do we have here? 1, 2, so we're going to have 2 logs here. So we're going to do log base C of 1 minus log base C of 4. Just expanding, kind of rewriting. All right, let's do this one together. So log base 3 of 5 minus log base 3 of 4. Okay, try number 4 on your own real quick. Look up here when you're done. Okay, so I got log y minus log x, or remember, you can put the 10 for your base. Okay, so one thing I want to remind you, if you didn't notice this already, but point out that always your numerator goes first. That's going to be what's first. And then your denominator is going to be the second one. Always. Because that's when we're going to eventually have to go and condense them. So we're going to start off with this, and then we're going to eventually go to that. So you've got to know that that first number is going to be what's in your numerator, and that second one is going to be in your denominator. Okay, good job, guys. Okay, flip over. Okay, so now let's put it into practice. Again, we're given log base 5 of 3 is equal to 0.683, and log base, let me change colors. Log base 5 of 7 is approximately equal to 1.09. Okay, so on this one, we're not having to try to figure out what the multiply, it just gives it to us. So let's expand this first. So we get log base 5 of 3 minus log base 5 of 7. And now we're going to substitute the numbers that were given in for these logs. So log base 5 of 3 is equal to 0.683 minus what our log base 5 of 7 is equal to 1.209. And we just subtract them our calculator. And what do we get? Let's see, we get approximately 0.526. So this you can just subtract in your calculator, you can do it in your head, whatever works best for you. Okay, good job. All right, now let's talk about the power property. This is the last one, the last new one we're going to talk about. So let's remind ourselves what happens when we raise a power to another power. So let's look at this. 2x squared raised to the third. Well, what do we do? What does our product property say in exponentials? Well, it says that we end up multiplying them, right? So we get x to the sixth. Okay, so now this is a little different in the sense that we're not raising a power to another power and multiplying them. So this one, what we're going to end up doing is look what the difference is from this one to this one. It is taking your exponent and it's moving it to the front of your log. And that's it. It's just moving it to the front of your log. That's not bad, is it? See, it just ends up moving straight over to the front of your log. And then we can expand the logs or we can evaluate them from there. And you'll see later on how that comes back to the multiplying from the power to the power. But right now, just know that you're just moving your exponent, moving your exponent to the front of your log. And so it becomes 4 log base 3 of 3. Okay, so do you guys remember those special product properties that we talked about? What happens when you have a log base 3 of 3 when these are the same numbers? What did we say? We said we could either cancel them out, especially if we had an exponent right here, but we don't. We can cancel them out and it becomes 1, right? So this becomes a 1, and look what we have up front here. We still have a 4, and so this just becomes a 4. Not too bad. Let's do another one. And these are all where it's like nice and pretty. So we can even use the special properties that we know. Look, cancel and it becomes a 17. But we need to be able to expand this and write them out because they're not always going to be the same. So if we expanded this, we would move the 17 to the front of the log, and we would get 17 log base 9 of 9. And then we know that these can cancel or really become 1, and you just get 17. Okay, so the point is, though, that you can see that you can expand these out, because what's going to happen is we're going to have some variables in there eventually, and we've got to know to bring the exponent to the front. So remember, exponent to the front, let's just expand this, and it becomes 2 log 729 of 729. Well, these are the same, so that becomes 1. So 2 times 1 is 2. All right, hopefully that's not too bad. So let's put them into practice with our log base 3 and log base 7. Okay, so how could we maybe rewrite 49 for there to be maybe an exponent? Well, we can rewrite 49 as 7 squared. Can we not? Well, don't we end up getting that exponent of 2? So we move it to the front, and we get 2 log base 5 of 7. Well, what do we know about log base 5 of 7? We know it is approximately 1.209, and we have our 2 in front. So if we multiply 2 times 1.209, we get approximately 2.418. And that is our answer. Okay, so we just did one a second ago. Let me go back. Oh no, we did it with a 3. So what if we just did, there's 2 ways to do this problem. You could also do log base 5 of 7 plus log base 5 of 7, because you know 49 is 7 times 7. So it's going to give you the same thing. Let's make sure. Log base 5 is 7, so 1.209 plus 1.209. Well, isn't that the same thing as saying 1.209 times 2, which is what we just did? Same thing, equals approximately 2.418. Okay. What if it's just a little bit harder? What if it looks like something like 27, log base 5 of 27? Well, we know that base 3 could be written as 3 to the third. So let's look at this. If we change 27 and rewrote it to a base of 3, because really that's what we're looking for, base of 3. Because I don't know anything with a 7 that I could rewrite it as 3 times 7 is 21. That doesn't work. So I've got to look at a base of 3. So look, we get log base 5, 3 to the third. Well, what can I do with that lovely exponent? Move it to the front. So I get 3 log base 5 of 3. Well, I know log base 5 of 3 because it's given to me in our problem. Let's see what it says. 3 times 0.683. So calculator's out. Do that in your calculator. You get approximately 2.049, I believe. Check my math. Okay, I'm going to pause here. I'm going to start another video because this one's getting kind of long. And then we're going to actually put these into practice, and we're going to expand until we can't expand anymore.